Okay. Go and open your book to page 348. So today's lesson is on how to use the remainder theorem and the factor theorem. Okay. So those two theorems are very useful. So what this will do is that first let's go over the remainder theorem. Okay. Remainder theorem, you can use the remainder of the synthetic division to do evaluation. So for example, if you look at example 1, so you have p of x is equal to x to the 4 minus 9x squared minus 2x plus 5. Okay? And you want to evaluate when x equal to negative 3. So you want to evaluate p of negative 3. So when you evaluate, so I'm going to go over the regular method. So normally, you want to evaluate when x equal to negative 3, you just substitute, right? So p of negative 3 would be negative 3 to the 4th power minus 9 times negative 3 squared minus 2 times negative 3 plus 5, right? Again, you want to evaluate, you just substitute, then you work it out. So p of negative 3 is equal to 81 minus 81 plus 6 plus 5. So p of negative 3 is equal to 11. Okay? So this is your regular way of evaluation. Now, you can use remainder theorem to evaluate. Okay? So let's go over how to use remainder theorem. Remainder theorem says that you can use synthetic division to divide, and then whatever remainder is, it would be your evaluation. So for example, like over here, when you're ready to use a synthetic division, right? So this is 1, 0, right? That's x cubed, minus 9, minus 2, and 5, right? And you want to evaluate the negative 3, so you put a negative 3 over here, right? And you use a synthetic division. So drop, multiply, you add, multiply, you add, multiply, you add, multiply, you add. Okay? Now remember, this is remainder, right? Now what did you see over here? Same, right? So that's why this is called remainder theorem, because the remainder is same as evaluation. So they are interchangeable. Okay? So we're going to evaluate a polynomial. You can use a synthetic division to divide, and your remainder would be your evaluation. Okay? So your answer would be 11. And that's how you use the remainder theorem. So remember, the remainder and the evaluations are interchangeable. Okay? So remainder and the evaluation are interchangeable. So, and this is much easier to do, right? Because this one is sometimes, especially if the exponent is big, you kind of have to use calculator, right? And this one is easy. You drop, multiply, you add, multiply, you add, multiply, you add, multiply, you add. Then you're there. Okay? So again, this is called remainder theorem. Remainder theorem means the remainder can be used to do the evaluation. Okay? Now, we're going to do the opposite. Now, keep in mind now, remainder and evaluation are interchangeable, right? So now, we're going to go to the factor theorem. Okay? So, factor theorem says that if a polynomial is a factor of the other polynomial, then it would divide exactly. So remainder would be equal to 0. Okay? So again, if the first is a factor of the second, then it would divide exactly with remainder equal to 0. Okay? So let's go to example 2. So we're going to use factor theorem now. Okay? So it asks, okay, is x plus 1 a factor of x to the 15 minus 3x minus 2. So is this a factor of this? Well, if you don't know about the theorem, then what you need to do is you have to go and divide it out, right? So let's say if you don't know the theorem. So you have to test out, see if it's a factor. Then this is what you need to do. Okay, so don't do this. Okay, so you have to go x to the 15, then you have to plus 0x to the 14 plus 0x to the 13 plus 0x to the 12. You have to go all the way down, and you have to minus 2, right? Then you have to do this, and you have to divide, right? So even when you use synthetic division, it's still kind of long because you have to go 1, you have to go 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, so 15, 14. So you have to do all these, okay? Then you have to do this. So even when you use synthetic division, it's kind of cumbersome, right? Okay, so don't do that. So we're going to use something called a factor theorem, okay? So remember now, so you want to test, see if this is a factor of this. So if this is a factor of this over here, that means you can divide exactly, means remainder would be equal to 0, right? Okay? So remember what we did earlier, right? See, remember the remainder and evaluation are interchangeable, right? They are the same, right? So before we use a remainder to do the evaluation, right? So now we're going to do the reverse. We're going to do evaluation to find the remainder, okay? So we're going to use a evaluation to find the remainder. So over here, if you solve, right? If you solve for x, the root would be x equal to -1, right? Okay? So we're going to evaluate what happens when x equal to -1. So we're going to evaluate that. Okay? Evaluate this polynomial at -1. Okay? So -1 to the 15th power minus 3 times -1 minus 2. So this will equal to -1 plus 3 minus 2. So this will equal to 0. Right? So evaluation equal to 0. Right? Now remember what we learned earlier, right? The evaluation and remainder are interchangeable, right? So if the evaluation is 0, that means the remainder will equal to 0, right? So if remainder equal to 0, that means it divides exactly. That means yes, this is a factor of that. Okay, so answer is yes. Okay? So you don't want to do that super long division. So the remainder theorem and factor theorem, they are reverse of each other. And the key point to remember is that the remainder and the evaluation are interchangeable. They are the same. Okay? So over here, you use the remainder to find the evaluation. Over here, you use the evaluation to find the remainder. And once you know the remainder is 0, then means it divides exactly, means yes. Okay? Okay, now let's go to example 3. So example 3 on page 350, it says find a polynomial whose roots are 1, -1, and 2. Okay, so you have R1 equal to 1, R2 equal to -1, and R3 equal to 2. So you're looking for the polynomial. Okay? So you kind of have to go backward. Okay? So remember where this came from, right? So this came from x minus 1, right? When you solve x minus 1, that's how you get 1, right? This one came from x plus 1, right? So when you set this equal to 0, you solve, that's how you get that, right? And when you, so polynomial, p of x is polynomial, that's the one you're looking for. So p of x equal to x minus 1, x plus 1, and x minus 2. Right? So again, from the roots, you get a factor, and from the factor, you multiply everything out. So you have to kind of go and distribute and multiply out. So this will equal to this. These are conjugate. So this will give you x squared minus 1. Right? So you always multiply the conjugate first. They will make things a lot easier. Okay, so now you multiply out. So you're going to get x to the 3 minus 2x squared minus x plus 2. And that's it. That's your polynomial. Okay? Okay. And let's go and do the same thing. So let's go to example 4. So this is when they give you the roots, you have to get a polynomial. Now example 4, they give you the equation and you have to solve. So example 4, so notice they go by pair, right? So over here, these two are opposite of each other, right? So these two are opposite of each other, right? Over here, you have the roots, you're looking for polynomial. Over here, they give you the polynomial equation, you have to look for roots, right? Okay, so you're solving. So you got x to the 3 minus 2x squared minus 3x plus 10 equal to 0, and R1 equal to negative 2. Okay? Okay, now, if this is a root, that means it came from the factor that can divide exactly, right? Like if it's a factor or roots, it means you can divide exactly. So what you want to do is you don't have an equation or the formula to solve for the cube, right? So you want to lower it down to square, then you can use quadratic formula or factoring, right? You learned about how to solve the quadratic equation before, but you don't know how to do a cube yet. So what you want to do, you want to lower these things down, okay? So that's going to use synthetic division. So 1, negative 2, negative 3, and 10. Okay, now this is already the root already, so you don't have to solve. So you can just take straight onto here, okay? So negative 2, okay, so you drop, multiply, you add, multiply, you add, multiply, you add. And you always have to equal to 0 because it's a root, means you have to divide exactly. So if your remainder is not 0, means doing something wrong, okay? So you use the polynomial to divide this factor over here. This is what you can end up with. So in other words, what you have left over is x squared minus 4x plus 5 equal to 0, okay, from here. That's what this is, okay? So again, when you use this came from x plus 2, okay? This came from this. So this polynomial divided by this polynomial, you end up with this. So now you know how to solve this, right? So again, the concept is you want to use synthetic division to lower your degree, and then from there you can go and solve. So from here, you can use master product, right? So you can use 1 comma, let's see. This one is not factorable, okay? If you try to match, so it's not factorable, so you can do factoring. Okay, so that means you use quadratic formula, right? So a equal to 1, b equal to negative 4, c equal to 5. So x equal to negative b plus or minus square root of b squared minus 4ac over 2a, right? So x equal to 4 plus or minus square root of 16 minus 20 over 2. So x equal to 4 plus or minus square root of negative 4 over 2. Okay, so you're going to get x equal to 4 plus or minus 2i over 2. So x equal to 2 plus or minus I. Okay, and that's how you do this. Okay, so let's go ahead and do some practice.